Well, you see, there is a quiet kind of wonder that settles over us when we ask a simple question: what truly makes a world a world? And, perhaps before we even begin to talk about Pluto or planets or the cold frontier beyond Neptune, I'd like to start with something that tugs gently at your curiosity. Have you ever looked up at the night sky and felt, just for a moment, that one tiny speck among the stars was calling your name? As if some distant little world, drifting in the dark, was asking you to remember it. Pluto often feels like that, a wanderer on the edge, and yet it somehow finds a place in our stories, in our emotions, in the soft corners of our imagination. And that is the thing. Long before definitions and debates, Pluto was something we loved. A small, icy body discovered with patience and hope. A faint whisper of motion across the black canvas of space. Why did it take so long for us to find it? Why did it charm the world the moment we finally did? And what does it say about us? That we felt both wonder and a strange sorrow when its title shifted. You know, these questions linger, like echoes in a vast cosmic hall. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. Well, you see, when we step back into the early days of Pluto's story, there is this gentle sense of anticipation, as though the universe itself was holding its breath. And, perhaps that is where every great discovery begins, not with certainty, but with a kind of longing, a question whispered into the dark. For decades, astronomers suspected that something small and elusive was tugging ever so slightly on the orbits of the giant planets. A subtle nudge here, a faint irregularity there, as if an unseen companion were drifting beyond Neptune, leaving only the softest footprints on the fabric of space-time. And that is the thing. Those clues were not loud. They were not dramatic. They were almost shy. But they were enough to set a handful of patient observers on a quiet hunt for a world no one had yet seen. One of them was Clyde Tombaugh, a young man working at Lowell Observatory. He was not the kind of figure you might imagine in the myths of exploration. No heroic voyager riding comets or climbing icy alien peaks. He was simply someone who looked carefully, night after night, comparing photographic plates by hand, searching for the faintest flicker of motion against a sea of stillness. And you know, that kind of work requires a certain temperament, a calmness, a willingness to trust that even the smallest shift of light, barely more than a grain of dust on glass, could reveal a world. Tombaugh had that patience, that quiet devotion to detail, and perhaps that is why, after so many nights of scanning the heavens, he finally saw it, that tiny wandering dot that refused to stay still. When Pluto was announced to the world in the year written as 1930, there was a ripple of awe that spread across continents. Imagine hearing, for the first time, that the solar system had grown, that there was a new world at the fringes, a world so distant that sunlight there arrived as something pale and thin, like an old memory of the warmth we know here on Earth. People looked up and felt the horizon of their understanding stretch just a little further. But the truth is, it took far longer to find Pluto than many expected, because it was not the world astronomers had imagined. They thought it would be larger, heavier, a mysterious planet whose gravity visibly stirred the outer giants. Instead, Pluto revealed itself as something far more delicate, a world small enough that its presence blended almost perfectly into the background of stars. Well, that meant the earliest tools struggled to capture it clearly. Telescopes in those days could not simply sweep the sky with digital precision. Instead, the search depended on a tedious craft, layering photographic plates taken weeks apart, then sliding them back and forth under a machine called a blink comparator. If a point of light moved between exposures, even ever so slightly, it betrayed itself as something real, something orbiting the sun. For Tombaugh, This method was as much meditation as science, a slow communion with the cosmos, and that is why his discovery still inspires such admiration. It was not luck, it was perseverance. But the early observations also led to confusion. Some astronomers mistook Pluto for a star or even a small asteroid at first because of how weakly it shone. Only by tracking it over weeks did they notice its arc, a careful, graceful curve through the dark. That motion was the signature that told them, yes, this is a world, not just a spark of background light. And, here is where the story turned slightly. Once Pluto was confirmed, scientists realized something unexpected. It was much smaller than they had predicted when formulating the original search for Planet X. They had imagined a giant shepherd of orbits, yet what they found was closer in size to our moon. But sometimes, discovery does not answer questions. It rewrites them. Still, the moment Pluto stepped into the stage of human awareness, it was greeted with joy. Headlines celebrated the expansion of our cosmic neighborhood. Children learned a new ninth planet. There was a feeling, I suppose, that the universe had gifted us something gentle, something distant, but somehow charming. It is curious how a world so cold and dim could evoke something warm in us. Perhaps it is because Pluto seemed, from the start, like a survivor of the early solar system, a relic left untouched in the far and frozen beyond. And in a way, the scientific community sensed that, too. They spoke of it with wonder, imagining mountains of ice and winds slower than a whisper. They pictured a world where seasons lasted longer than human lifetimes, and where the sun hovered like a pale star rather than a blazing disk. As more observations accumulated over the following decades, the excitement did not fade. Instead, people grew attached to the idea of Pluto, this tiny wanderer with its tilted orbit and curious behavior. But during those first years, the science was still fragile. Measurements of its diameter fluctuated wildly. Some estimates were far too large, remnants of the old assumption that it must be heavy enough to perturb distant planets. Later, as instruments improved, the truth began to settle. Pluto was not a giant at all, but an unexpectedly lightweight traveler. And there is something poetic about that, you know. The world we spent so long searching for was never the towering figure we imagined. It was a whisper, not a shout, a subtle note in the grand cosmic symphony. And yet, because of its very smallness, its very delicacy, it offered something else, a glimpse into an ancient region of space where fragile worlds drift quietly, untouched by the warmth that shapes inner planets. The reaction among astronomers at the time was a mix of celebration and curiosity. Pluto was a puzzle. It forced scientists to rethink gravitational calculations, to refine their models, and to consider that perhaps the outer solar system was far more strange and populated than they had ever suspected. As they measured its faint motions and reconstructed its path, they realized just how unusual its orbit was. Not circular, not even close, but elongated, stretched out like an oval loop carved through deep space. And inclined too, angled dramatically compared to the other planets, as though Pluto were dancing to its own tempo. All of this made astronomers pause. If Pluto was so different, then what did it represent? Was it a planet in the same sense as the familiar 8 interior worlds? Was it something else entirely? You see, these early questions did not yet challenge Pluto's title, but they planted a seed, one that would grow slowly, quietly, over many decades. And the fascinating part is that no one realized, in those early years, that this little icy dot would someday ignite one of the most emotional debates in modern astronomy. Yet even as the scientific questions deepened, the human connection remained. Pluto had charmed the world. It appeared in textbooks, in planet models, in childhood songs about the solar system. The idea of 9 planets felt complete, balanced, comforting. Perhaps that sense of completion made Pluto feel larger than its physical size. It became, in a way, a symbol of the frontier, a reminder that the universe still held secrets. But discoveries, well, they always invite more discoveries. And the more we learned about Pluto, the more the mysteries began to multiply. Its faintness, its remoteness, its strange behavior all hinted at something waiting beyond it, something bigger, something shared, a region filled with icy remnants left from the solar system's birth, a region we had not yet understood. And that quiet suspicion, that pull toward the unknown, would eventually lead astronomers to uncover an entire realm of worlds inhabiting the same distant frontier as Pluto, a revelation that would reshape our understanding of its place in the cosmos. But for now, let us stay with this moment, this early chapter in Pluto's life, where discovery felt like a triumph and questions whispered softly along the edge of the solar wind. Because as we move forward, toward the next part of the story, we begin to sense that Pluto was never alone out there, not truly. And perhaps that realization is the very doorway into the chapter that follows, where Pluto steps from solitary wanderer into something far more complex and wondrous. Well, you see, when we step softly into the era after Pluto's discovery, there is this warm and almost innocent certainty that settles over humanity, as though the cosmos had finally revealed the last missing piece of a familiar puzzle. And, perhaps that is why, for so many decades, Pluto lived peacefully in our imaginations, as the ninth planet, perched far beyond Neptune, like a quiet lantern glowing at the edge of the sun's domain. In those early years, no one questioned its place. It stood unchallenged at the outermost frontier of the solar system, a tiny sentinel guarding the border between the known and the unknown. Children memorized its name with the same affection they had for Earth or Mars, tracing its orbit on classroom posters that showed it looping in a delicate arc around the sun. You know, in those textbooks, Pluto was simply the ninth planet, the last stop on that long journey outward. The diagrams often exaggerated its size a bit, making it look more companionable, easier for young minds to grasp. There it was, a small but sturdy bead of light, faithfully orbiting the sun, just as the others did. And perhaps, because it sat at the periphery, it felt almost mythic. A world of mystery, barely touched by warmth, wrapped in darkness like an ancient relic waiting to be understood. The reason it entered the planetary list so readily was simple. At the moment of its discovery, nothing else quite like it was known. Astronomers assumed that if it orbited the sun and was more massive than an asteroid, then surely it must be a planet. The catalog of the solar system was still young, still flexible, still shaped by expectation as much as by measurement. And Pluto, even though small, fit neatly into the structure. It was easier to welcome it than to question it. After all, scientific humility is often learned only after new evidence insists upon it. For decades, no one doubted its status. Why would they? We had no reason to imagine countless icy bodies lurking beyond Neptune, no reason to question whether Pluto was unique or simply the first hint of a larger family. The telescopes of the time lacked the sensitivity to peer into the deep shadowed regions of the outer system, so Pluto felt alone, sovereign, a solitary wanderer with a title that seemed unshakable. Well, I suppose another piece of this quiet certainty came from the first images humankind managed to capture of Pluto. They were little more than fuzzy specks, trembling on photographic plates, barely resolved against the night sky. But even these faint portraits held a kind of charm. They reminded us that the universe is vast, and that even the smallest world is worthy of our attention. Early illustrations in scientific books painted Pluto as a bluish or grayish sphere, smooth and cold, a kind of miniature companion to the giants. Artists imagined craggy ice fields, distant twilights, a sun so small it resembled a star more than the blazing disk we know. And students, flipping through their pages, would stop at Pluto as though it were a final chapter, a full stop at the end of a cosmic sentence. But, the confidence of that era was built on very limited data. We knew Pluto had a peculiar orbit, one that occasionally brought it closer to the sun than Neptune. We also knew its path was tilted, as though it had been nudged or sculpted by forces we didn't yet understand. Still, astronomers assumed these quirks were simply part of its personality, characteristics that made the outer solar system delightfully strange. They trusted that the solar system, as it had been taught for generations, was complete. There was a sense that the map was finished. Yet, perhaps beneath that sense of completion, there was always a whisper of discomfort. Pluto's orbit defied our usual expectations. It cut through the plane of the planets like a line drawn at an odd angle, as if refusing to follow the orderly path set by its larger siblings. Sometimes astronomers would linger on this oddity, wondering what gravitational events might have twisted its trajectory so dramatically. But questions can be quiet things, easy to set aside when the prevailing story is so comforting. Children, though, rarely noticed any of these complexities. For them, Pluto was simply the little planet at the end of the line. Teachers would flip to the final page of the solar system chapter and say something like, "Here it is, the 9th planet, the farthest world from the sun, cold and dark, but still part of our family." And there was a kind of emotional resonance in that. Pluto felt like the shy youngest child, distant but beloved. Perhaps that affection made it harder many years later to accept any change in its status. And the truth is, the scientific community held on to its belief with similar warmth. Even when early measurements began to suggest Pluto was smaller than previously imagined, there was still no real hesitation. After all, planets vary widely. Mercury is small, Mars is only half the size of Earth, and there was nothing to suggest that a small planet could not exist at the solar frontier. The idea that Pluto might be a kind of wanderer, a strange and solitary outpost, only enhanced its mystique. But the illustrations in older textbooks, well, they revealed something fascinating in hindsight. They often depicted Pluto with a smooth, featureless surface because no one knew what it looked like. It was too far, too dim, too shy to reveal itself clearly. Yet that very lack of detail also allowed imagination to flourish. In documentaries and popular science magazines, Pluto was drawn as a frozen marble, a lonely pearl adrift in an endless night. And those images solidified our belief that we understood it, even though, in truth, we hardly knew it at all. The trust placed in Pluto's orbit was also shaped by imagination. Astronomers once believed its odd path might hold clues to the formation of the outer solar system. Some theorized it had been a moon of Neptune that strayed too far and escaped. Others believed a collision early in solar history had knocked it into its eccentric path. These ideas, while speculative, made Pluto feel like a survivor, a remnant from an era before Earth had even cooled. And yet, all the while, Pluto held its place in the solar system model like a delicate bead on a string. Its identity as the 9th planet became so deeply ingrained in global culture that it transcended science. It appeared in school songs, in planet mobiles hanging from classroom ceilings, in the imaginations of children who drew smiling faces on it and gave it personality. Perhaps that is why the emotional bond formed so early and so strongly. It was not just a world, it was a story. If you look back at the mid-20th century, you can almost picture young students mapping out the solar system as a line of orbits stretching further and further outward until finally reaching Pluto. It gave the universe structure. It made it feel navigable. One could say, here is home, and here are our neighbors, and here is the cold, dark frontier where the last of our planetary family resides. You see, there was something soothing about that. A sense that humanity had charted the distances and found an orderly pattern in the vastness. Well, as time passed, the certainty that Pluto was the 9th planet hardened into tradition. It became common knowledge, and common knowledge, once settled, is difficult to unsettle. But science, unlike sentiment, grows restless when confronted with unanswered questions. And soon, faint clues from the far reaches of space suggested that Pluto's story was far from complete. Observations hinted at something strange. Pluto might not be alone. Its orbit, its size, its peculiar behavior suggested the presence of other icy bodies lurking beyond Neptune, unseen but influential. And this quiet suspicion would eventually blossom into one of the most important discoveries of the late 20th century. But for now, in this moment of history, Pluto still held its crown, gleaming softly at the solar frontier, the enigmatic ninth planet. And yet, even as humanity embraced that story, the universe was preparing to show us something humbling, something that would shake our assumptions and invite us into a deeper mystery. For Pluto's place as the final planet was never the end of the map. It was the beginning of a doorway, one that would open onto an entire realm of frozen worlds scattered like ancient pearls across the outer dark, a realm we had not yet dared to imagine, but one that would soon reveal itself as the next chapter of our cosmic understanding. And perhaps, as we step closer to that threshold, we begin to sense that Pluto's loneliness was always an illusion, because just beyond it, waiting patiently in the shadows, was an entire kingdom of worlds that would reshape everything we thought we knew. And that, well, leads us gently into the next chapter. Well, you see, as we drift farther from the warm glow of the sun and step into Pluto's realm, something remarkable begins to happen. The familiar scale of planetary life collapses, reshapes itself, and invites us to rethink what a world can be. And, perhaps that is where the quiet beauty of Pluto truly lies, not in its grandeur, for it has little of that, but in the way it humbles our expectations. If the 8 classical planets are like orchestral instruments, bold and resonant, then Pluto is a single, delicate note that somehow lingers in the air far longer than it should. And that is the thing. When you first try to imagine how small Pluto really is, your mind balks a little. We tend to think of planets as mighty bodies, wide enough to hold entire continents and deep enough to cradle oceans. But Pluto, well, it is more modest, much smaller than Earth, not even half the width of our moon. You could, in a sense, wrap your imagination around it with both hands. And still, despite that smallness, it exerts a gravitational presence that holds its own moons in a slow and intricate dance. It is proof, I suppose, that size is not always the sole measure of significance. Pluto's mass is equally surprising. If Earth were reduced to a single grain of sand, Pluto would be no more than a speck of dust beside it. And yet, even that speck carries stories within it. Compressed into its icy heart is the memory of the early solar system, a fossil of frozen nitrogen, methane, water ice, and rock. Scientists once believed it must be heavier, more forceful, capable of tugging on Neptune's orbit. But as we came to measure it more precisely, we learned that Pluto was gentler than expected, a lightweight traveler drifting through shadows. Its small mass is not a flaw but a clue, whispering that Pluto may have formed in a region where material was sparse, where worlds were born not from abundance, but from the slow gathering of the faintest traces of matter. And then there is its orbit, that wild, poetic gesture drawn across the sky. Unlike the planets that follow near perfect rings, Pluto moves like a dancer stepping out of line, crossing the plane of the solar system in a slanted sweep. Its path is so elliptical that at times it drifts closer to the sun than Neptune, only to retreat later into a darkness so deep that sunlight becomes little more than memory. Orbits are like signatures. They tell us something about a world's history, the gravitational conversations it has had over billions of years. And Pluto's signature reads like a story of encounters, of nudges and negotiations. Perhaps with Neptune, perhaps with other icy wanderers we have yet to discover. Pluto's tilt is another whisper of strangeness. While Earth leans modestly at just over 23 degrees, Pluto inclines dramatically, lying almost on its side relative to the sun. Imagine seasons that stretch on for decades, nights that last entire human generations, and days that come slowly, softly, as though time itself has chosen to move differently there. Perhaps that is what makes Pluto feel so remote, not just its distance, but its rhythm. It spins and tilts with a kind of cosmic patience, inviting us to remember that not all worlds follow the same clock. And speaking of distance, well, Pluto resides in a place where the sun's warmth is faint, fragile. At its closest approach, the sun is still a dim star in the sky, hardly brighter than a winter's afternoon. At its farthest, sunlight takes hours to arrive, stretched thin across the void, barely touching the frozen surface. Temperatures plunge so low that even nitrogen becomes ice, and methane hardens into frosty plains. It is a world sculpted by cold, a world where each breath of wind is slow, where landscapes shift not by storms, but by the delicate sublimation of frozen gases. You see, when we talk about sunlight on Pluto, we must imagine something barely recognizable. A pale, diluted glow. Shadows not sharp, but soft. And I suppose that tells us something profound about perception. We often assume darkness is empty, but on Pluto, darkness is a realm full of texture. The interplay of faint light and deep cold creates patterns we have only just begun to understand. Even a small change in sunlight can alter the surface, causing ices to migrate, cliffs to form, plains to recede. Pluto's environment is not lifeless. It is subtle, responsive, patient. Its rotation adds yet another layer of peculiarity. Pluto spins slowly, as though it is in no hurry to greet the sun again. A single day there lasts longer than 6 days on Earth. But more than that, it rotates in a synchronous dance with its moon Charon, each always showing the same face to the other. There is something poetic about that. Two worlds locked in perpetual contemplation, turning together through the void. This slow spin gives Pluto an almost meditative quality, as if time thickens around it. And perhaps, in contemplating these differences, we begin to sense the deeper truth. Pluto is not an odd planet. It is a different kind of world altogether. A world shaped by conditions far removed from the inner solar system. A world that teaches us that diversity is the rule of the cosmos, not the exception. When we compare it to Earth or Mars, we misread its story. Pluto belongs to a colder, quieter neighborhood, sculpted by ancient remnants and distant sunlight. Yet even these features, remarkable as they are, hint at something more. Something beyond Pluto itself. Because when astronomers began to realize how unusual Pluto was, how unlike the planets we thought we understood, they also began to wonder whether this uniqueness was an illusion. Was Pluto truly an outlier, a solitary, eccentric traveler, or was it merely the first clue to a much larger community of icy bodies? And that question, you see, is what begins to open the door to the next chapter. For Pluto's small size, its meager mass, its tilted orbit, its frigid temperatures, its faint sunlight, and its slow spin all point toward an origin shared with others, hidden somewhere in the deep outer dark. A place where countless icy worlds may drift, waiting for us to notice them. Perhaps Pluto was never meant to stand alone. Perhaps it was simply the first voice in a quiet chorus, a herald of a vast frontier that would one day reshape our understanding of the solar system and remind us, gently but firmly, that the universe is always larger, stranger, and more wondrous than we allow ourselves to believe. And so, as we step forward, the path leads us naturally outward, beyond Pluto itself, into the region where it truly belongs, a region known as the Kuiper Belt, a realm of frozen worlds scattered like ancient seeds across the outer darkness, a realm that will soon reveal why Pluto is the way it is, and why its story is far from solitary. Well, you see, as we move outward from Pluto itself and let our imagination drift into the dim outskirts of the solar system, something astonishing begins to unfold. It is as if the darkness, which once seemed empty and silent, suddenly reveals a hidden architecture, a vast and ancient kingdom of icy fragments suspended in slow motion. And, perhaps this is the moment when the story of Pluto truly deepens. Because the more we look into this distant region, the more we understand that Pluto was never alone. It was only the first voice we heard in a chorus too faint for early telescopes to detect. Astronomers call this enormous region the Kuiper Belt, and though the name may sound technical, the idea behind it is wonderfully simple. Imagine, if you will, a great ring encircling the sun, far beyond Neptune, filled with billions of frozen bodies. These objects are remnants from the solar system's earliest days, untouched debris from the time when planets were still forming, drifting like ancient seeds in a cosmic garden. The Kuiper Belt stretches outward for billions of kilometers, a frontier of ice and silence that circles the sun at a distance where warmth fades into memory. And that is the thing, really. For so long we assumed the solar system ended neatly at Neptune, as though someone had drawn a line and said, "This far and no further." But nature rarely respects our tidy diagrams. Instead, it extends itself in unexpected ways, reminding us that our maps are only the beginning. Pluto sits within this vast ring, not at the center, not at the edge, but woven into it. A citizen of a realm that humanity simply did not know existed for most of its scientific history. For decades, scientists believed Pluto was a solitary wanderer, a lone world circling the sun on its peculiar orbit. And yet, once we began to explore the Kuiper Belt more seriously, the picture changed. Suddenly, objects were discovered one after another, some small, some surprisingly large, all drifting together in that cold expanse. And as those discoveries accumulated, a quiet realization began to grow. Pluto was not an anomaly, it was a clue. These other bodies, often called Kuiper Belt objects, share similarities with Pluto in size, composition, and orbital behavior. They are icy, faint, irregular in shape, and many follow tilted or elongated paths just like Pluto does. Some of them even approach Pluto in scale. One object, later named Eris, turned out to be roughly comparable in size to Pluto itself, and that simple fact, innocent at first glance, would eventually ripple through the scientific world and force us to ask uncomfortable questions about what a planet truly is. But before we reach that debate, we need to understand just how populated this region is. Scientists now estimate that there may be hundreds of thousands of objects in the Kuiper Belt larger than 10 kilometers across, and perhaps trillions of smaller ones. You know, when you imagine that many icy fragments floating beyond Neptune, it becomes clear why Pluto no longer seems so unusual. It is extraordinary, yes, but extraordinary in the way a particularly bright star appears in a constellation. It stands out, but it belongs to a larger pattern. And, that belonging is important because it tells us that Pluto is not the final planet of the solar system, as we once believed, but the first representative of a new class of worlds that inhabit the deep frontier. For a long time, though, the Kuiper Belt was invisible to us. Not because it was small, but because it was faint. The sunlight that reaches such distances is weak, too weak to illuminate the frozen surfaces with clarity. Our telescopes simply could not see these objects until technology caught up. For most of the 20th century, the outer solar system was imagined as a vast emptiness with Pluto as its solitary occupant. This illusion persisted because the light reflecting off those distant objects was scattered thinly across the void, dissolving before it could reach our instruments. Even the idea of a belt lurking beyond Neptune had been proposed, theoretically as early as the mid-20th century, but without visual confirmation, it remained speculative, like a rumor whispered in the dark. It was only in the final years of that century, as digital detectors improved and wide-field surveys became more sophisticated, that the truth began to emerge. One icy world was found, then another, then dozens more. They varied in brightness, in orbit, in size, but together they formed a pattern that made the existence of the Kuiper Belt undeniable. And scientists began to marvel at the oversight. How had we missed an entire region of the solar system? How had our maps been so incomplete? And I suppose the answer is humbling. The universe reveals itself slowly, only when our tools and our curiosity sharpen enough to notice. You see, the discovery of this belt was more than a scientific breakthrough. It was a shift in perspective. It forced us to rethink how the solar system formed. Instead of imagining the planets emerging cleanly from the swirling disk of matter around the young sun, we began to see a more complex picture, a place where leftover fragments remained frozen and untouched, preserving the chemical conditions of the early solar disk. The Kuiper Belt, in this sense, is not just a location. It is a time capsule, a museum of cosmic origins suspended at the edge of daylight. And within this museum, Pluto is both a masterpiece and a messenger. Its orbit, its composition, its size, its surface features all align with what we expect from Kuiper Belt objects. It is larger than most, yes, but not uniquely so. It is brighter than many, but still part of a continuum. And suddenly the idea of Pluto as the ninth planet began to seem strangely fragile, as if it were built on a misunderstanding of context. If you place a single snowflake on a dark table, it looks distinct, singular. But place it among 1,000 others, and it becomes part of a pattern, no longer isolated. Pluto, once thought to be a lone and puzzling world, was now recognized as one among many. That recognition led to an important question scientists had avoided for decades. If Pluto is simply one of many icy bodies in this region, then in what sense is it a planet? And if it is a planet, then should the others be planets as well? After all, some Kuiper Belt objects are only slightly smaller. Others share orbital resonance with Neptune, just as Pluto does. And the more scientists looked, the more they saw echoes of Pluto everywhere. The solar system, which once felt so tidy with its 9 planets, suddenly became complicated. And in that complication, a deeper beauty emerged, like discovering that the simple melody you learned as a child is actually part of a larger symphony, with hidden harmonies. But this region was not merely overlooked, it was misinterpreted. For decades, astronomers believed the outer solar system was too empty to support such a population. They assumed that any objects born there would have been scattered away long ago by gravitational encounters with the giant planets. And yet, the Kuiper Belt persists, a testament to delicate balances at the solar frontier. It exists because Neptune's gravity, rather than sweeping everything away, actually sculpted the region, creating pockets of stability where icy bodies could survive for billions of years. Pluto rests in one of these pockets, locked in a resonant dance with Neptune that ensures their paths never collide. This discovery was one of the great revelations of late 20th and early 21st century astronomy. It meant that Pluto's orbit, once dismissed as peculiar or erratic, made perfect sense in the context of the Kuiper Belt. It was not an exception, it was a defining feature of the region, and as this understanding deepened, scientists realized how incomplete their earlier models had been. The outer solar system is not empty. It is structured, shaped by gravitational harmonies we are only beginning to interpret, and the more carefully we observed, the more layered this region became. We found objects that wandered freely, objects locked into resonances, objects with binary companions, objects with surfaces coated in exotic ices. Each discovery added texture, as though we were slowly brushing away the dust from an old painting, watching details emerge stroke by stroke. And in this widening landscape, Pluto's uniqueness softened. It was no longer the strange child of the solar system. It was one of the elders of the Kuiper family, a world with companions stretching across millions of kilometers. This realization also reshaped our emotional connection to Pluto. Its demotion from planet to dwarf planet, though painful for many, was not an insult. It was an acknowledgement of truth. Pluto had been placed in the wrong category simply because we lacked the data to place it correctly. And, in a way, that correction reflects the humility of science. We update our understanding not because we wish to diminish a world, but because the universe keeps offering us more detail, more nuance, more truth than we had before. But even with these insights, the story of the Kuiper Belt remains unfinished. There are hints of larger objects still undiscovered, shadows detected in orbital irregularities, whispers of worlds waiting for telescopes not yet built, and in the coming decades, especially as we approach eras like 2025 and beyond, we may learn that the Kuiper Belt is even more complex than we imagine today. Yet before those future revelations unfold, we must sit with the point that Pluto, for all its charm and peculiarity, is simply one jewel in a vast crown of icy bodies. A remarkable jewel, yes, but part of a constellation of stories stretching across the solar system's distant edge. And once you see Pluto in that light, the next question becomes unavoidable. If Pluto belongs to this belt, and if this belt is full of similar worlds, then how do we decide what a planet truly is? What rules define the difference between a planet, a dwarf planet, and an icy remnant? And that question, whispered softly at the boundary between fact and philosophy, invites us gently into the next chapter. A chapter where science attempts to define the very thing it once took for granted. A chapter where Pluto's identity is tested not against emotion, but against criteria that reach toward the essence of what makes a world a world. Well, you see, by the time humanity had uncovered the vast icy realm of the Kuiper Belt and realized Pluto was only one among countless distant worlds, a quiet but profound question began to shimmer at the edge of scientific thought. What, exactly, is a planet? And, perhaps it seems like the sort of question a child might ask while gazing up at a mobile of colorful spheres hanging above their bed. Yet even the greatest astronomers of our time found themselves pausing, hesitating, searching for an answer that felt truthful rather than traditional. Because for centuries the word planet was less a scientific category and more a story we told ourselves about the wandering lights in our sky. But as our tools sharpened and our maps expanded, that story became harder to maintain. And that is the thing. When new worlds begin to appear, worlds that do not fit our tidy expectations, the language we use to describe the cosmos must evolve. So in the early 21st century, the scientific community gathered to decide, officially and deliberately, what separates a planet from everything else drifting through the sun's domain. This responsibility fell to the International Astronomical Union, the organization entrusted with naming and classifying celestial objects. For many people, the decision seemed simple, but for astronomers who understood the complexity of the solar system's architecture, the stakes were enormous. They were not merely assigning labels. They were attempting to draw a boundary around a concept that had remained fuzzy for centuries. Well, you see, this effort culminated in a definition built upon three core conditions. The first condition was straightforward. A planet must orbit the sun, not a star, not a planet, but the sun itself. This rule excluded moons, asteroids captured by gravitational chance, and the countless icy bodies orbiting each other in shadowed corners of the solar system. For Pluto, this requirement posed no problem. Its orbit, eccentric though it may be, loops faithfully around the sun like a distant thread woven into the solar tapestry. The second condition was more intriguing, and perhaps more poetic in its own way. A planet must be massive enough for its own gravity to shape it into a sphere. This criterion acknowledges the quiet power of self-gravity, the inward pull that smooths away sharp edges and irregular shapes, sculpting a body into a rounded form. It is as though the universe recognizes planethood not by material wealth or brightness, but by an internal balance, a symmetry born of mass and time. Pluto, small though it is, satisfies this requirement beautifully. Its icy mountains and smooth plains rest upon a body pulled into roundness by the gentle insistence of gravity. But the third requirement, well, that was the one that shifted everything. A planet, according to this new definition, must have cleared its orbit, not swept it empty in a literal sense, but dominated it gravitationally, becoming the primary force shaping that region of space. The idea is subtle but profound. To clear an orbit is to rise above mere participation in the cosmic environment. It is to claim stewardship over a path around the sun, ensuring that smaller bodies either collide, merge, or get flung away by gravitational interactions. Earth has done this. Jupiter, with its vast influence, has sculpted entire regions of the solar system. Even small worlds like Mars have managed it. But Pluto, drifting through the dense population of the Kuiper Belt, has not. The phrase clearing the orbit might conjure images of a broom sweeping dust aside, but the reality is more complex. The Kuiper Belt is teeming with objects similar in size and composition to Pluto. They move alongside it, cross its path, accompany it through the sun's gravity well. Pluto does not dominate them. It shares space with them. And that sharing, gentle and unassuming, is enough to disqualify it from being a classical planet under this definition. One could say Pluto is part of a community rather than a ruler of a territory. And perhaps, in a philosophical sense, this is where the emotional conflict truly began. Because the third criterion elevates dominance over companionship, control over coexistence. It makes a planet something powerful, something that shapes rather than adapts. Yet Pluto, for all its beauty, is more like a participant in the cosmic flow, a world shaped by the environment rather than shaping it. And some people found that idea hard to accept. They wanted Pluto to remain special, not because of gravitational rules, but because of memory, affection, tradition. But science, you see, must choose clarity over sentiment. And for astronomers, this third requirement was essential. Without it, the solar system would suddenly have dozens, even hundreds of planets. Every spherical Kuiper Belt object, every large asteroid, every frozen fragment of the early solar disk would demand equal recognition. And in that sense, the definition protects more than a label. It preserves coherence, allowing us to distinguish between worlds that anchor gravitational neighborhoods and worlds that inhabit them. Still, understanding this does not make the transition any easier. Pluto satisfies the first two conditions flawlessly. It is a world shaped by its own gravity, a world orbiting the sun, a world with mountains, plains, atmosphere, seasons. But the third condition places it firmly among the dwarf planets, a category born from the very debate Pluto inspired. And, perhaps that feels unfair. Perhaps it feels as though the universe is being forced into boxes. But these boxes help us see relationships we might otherwise miss. Why do the larger planets meet the orbit-clearing requirement while Pluto does not? The reason lies primarily in mass and distance. Jupiter, for instance, is so massive that its gravitational influence extends across extraordinary distances. Earth, though small compared to gas giants, still commands its orbital region. But Pluto, tiny and distant, simply does not have enough gravitational authority to scatter or absorb neighboring objects. The Kuiper Belt is too dense, too populous. It is not something that can be cleared by a world the size of Pluto. And that fact, rather than diminishing Pluto, reveals something about the environment in which it lives. Pluto is shaped by a rich community of icy bodies that share its origins. You might imagine standing on Pluto's surface, looking out into the velvet blackness, aware that your world is only one among many drifting through that frozen wilderness. From there, the distinction between planet and dwarf planet must seem irrelevant. The cosmos does not assign labels. It only evolves. And perhaps the labels we use say more about our need for structure than about the worlds themselves. Still, the decision made by the International Astronomical Union had far-reaching implications. It clarified our understanding of the solar system's architecture and forced scientists to refine the language they used. For the first time, planet became a well-defined category rather than a historical hand-me-down. And the subtlety of the definition inspired new questions. How should we classify exoplanets orbiting distant stars? How should we describe binary systems like Pluto and Charon? How do we reconcile cultural notions of planets with scientific realities? And as these questions echoed through classrooms, observatories, and debates, one truth became clear. Pluto's reclassification was not the end of its story. It was the beginning of a deeper exploration of what worlds truly are. You see, science grows through friction, through the discomfort of adjusting our understanding. And Pluto's fate forced us to examine our assumptions about celestial hierarchy, about what matters most when drawing boundaries in a universe that rarely respects boundaries at all. And perhaps the most poetic part of this entire conversation is the notion of orbit clearing itself. To clear an orbit is to impose order upon chaos, to create stability in a realm shaped by gravity's whims. But the Kuiper Belt, with its vast population of icy remnants, resists such order. It is a place where no single world dominates, where gravitational influences overlap, merge, and diffuse like ripples in a frozen pond. Pluto, with its modest mass and intricate orbit, embodies that quiet resistance to categorization. It reminds us that not all regions of the solar system behave like the orderly inner planets. Some regions preserve the ancient complexity of formation. Yet despite the logic of the scientific definition, emotion continued to cloud the conversation. To many, Pluto felt like a beloved character, unfairly removed from a familiar cast. It had been part of childhood songs, classroom posters, and imaginative journeys, and so its new identity as a dwarf planet triggered a kind of cosmic grief. But beneath that reaction lies something beautiful. It reveals how deeply we connect to the universe, how the worlds beyond our own become symbols of hope, curiosity, and longing. Still, the criteria crafted by the International Astronomical Union had to serve science, not sentiment. 3 requirements: clear orbit, spherical shape, solar orbit. Pluto's story transformed when it met the first 2, but not the third. And that truth, though difficult, allowed scientists to classify a vast array of newly discovered bodies in the Kuiper Belt with greater precision. But even now, as we sit with this definition, a subtle question lingers. Are these criteria final? Will we someday revise them again as our understanding deepens? The universe often refuses to stay within the lines we draw, and history shows that scientific definitions evolve over time. As new discoveries accumulate, especially in eras beyond 2025, the classification of planets may shift again. Perhaps a future generation will look back on our definitions the way we now look back on ancient astronomy, respectful yet aware that knowledge is always provisional. And so, as we transition from the abstract criteria of planethood into the concrete moment when Pluto's fate was decided, we feel the tension rising. For definitions are one thing, but declaring the identity of a beloved world is another. The stage was set for debate, for disagreement, for emotion and logic to collide in a way that rarely happens in science. And that collision, well, forms the heart of the next chapter. A chapter where astronomers from around the world gather to cast a vote that would echo far beyond their conference hall, reshaping not only the solar system's map, but the human imagination itself. Well, you see, by the time all the scientific arguments had settled into place and the definition of a planet had been shaped into those 3 careful conditions, the stage was already set for one of the most emotionally charged moments in modern astronomy. And, perhaps that is why the decision to reclassify Pluto still echoes so strongly today. It was not merely a scientific correction. It was a deeply human moment, the kind that reminds us that science, for all its precision, still unfolds within the hearts and minds of people who feel wonder, pride, doubt, and sometimes even grief. And that is the thing. The decision did not happen quietly in some remote office. It unfolded in a historic meeting, one that gathered astronomers from around the world, in a single place, under a single purpose, to decide definitively what Pluto was. This meeting took place during a General Assembly of the International Astronomical Union, hosted in a sprawling conference hall filled with rows of chairs, glowing screens, scientific posters, and the soft murmur of voices carrying in a dozen languages. Imagine, if you will, hundreds of scientists walking into that room, each carrying not only decades of research, but also the weight of tradition and the responsibility of reshaping the cosmic map that generations of school children had memorized. Well, the number of participants varied throughout the debates, as conferences often shift with sessions and schedules. But ultimately, it was a few hundred voting members present in that final moment who would raise their hands and cast their decision. And, that might seem like a modest number, given the scale of the question they were answering. But this is how scientific bodies function. Decisions are made by those who attend, those who are present when the question is called. The vote itself, contrary to the gentle image we might have hoped for, was not calm. It was the culmination of days of passionate discussion and sometimes heated argument. Astronomers spoke not only with logic, but with urgency, as though the identity of Pluto touched something fundamental about how we understand the universe. Some argued fiercely that Pluto should remain a planet, insisting that tradition and public understanding carried weight. Others insisted that the new discoveries in the Kuiper Belt demanded clarity, that science must evolve to describe the cosmos as it truly is, not as we grew up imagining it. And this debate, revealed something profound. Even in the most rational of fields, humans bring their emotions into the room. When the final vote was taken, the outcome was clear. Pluto no longer qualified as a classical planet under the newly adopted definition. Its orbit had not been cleared. It shared its region with countless other bodies. And so, by the essence of the third criterion, it did not stand alone. It did not dominate. It participated. And because of that, Pluto was gently but firmly placed into a new category, the dwarf planets. And, perhaps that was the moment when the air changed in the room. Some scientists nodded, some stared quietly, some felt relief, others felt a pang of loss. Well, the reasoning behind this decision was scientific, but the reaction to it was deeply human. Many of the astronomers in attendance later described the moment as bittersweet. They knew the decision was necessary, the evidence was overwhelming, but they also understood how iconic Pluto had become. It was the 9th planet. It was the enigmatic little world at the end of the solar system. It represented exploration, curiosity, and the thrill of discovery. To change its status felt like rewriting a familiar story, and then, of course, the news reached the world. I suppose one could say that this was where the real shock unfolded. Newspapers around the globe ran dramatic headlines. Broadcasters announced the demotion with tones usually reserved for political upheaval or economic collapse. It seemed unbelievable that a world that had orbited the sun long before humans ever looked upward, could lose its title because of a vote. And that is the thing. Pluto did not change. It remained exactly what it always was. But our definition changed, and language, not nature, shifted the way we spoke about it. For many people, the decision felt personal. Children who had grown up memorizing 9 planets felt as though something had been taken from them. Adults felt nostalgia for the solar system they had learned in school. Teachers and astronomers received hundreds of letters, some curious, some sad, some angry, all asking the same essential question: why? Why remove Pluto from the family? Well, the scientific answer was clear, but the emotional response lingered. Some people protested the decision publicly. Others created petitions. A few artists painted Pluto as a lonely figure drifting through space, holding a sign that read something like, "Still here." There were political cartoons. There were internet memes. There were even t-shirts printed with slogans defending Pluto's honor. The world, it seemed, could not imagine a solar system without its smallest and coldest planet. And, the media played a significant role in that reaction. Headlines simplified the debate into a dramatic narrative, painting scientists as villains or heroes depending on the perspective. Talk shows invited astronomers to explain themselves. Some defended the decision with calm logic. Others argued passionately for Pluto's reinstatement. Even late-night comedians joined the conversation, proving once again that science, when it touches the human imagination, spreads far beyond laboratories and lecture halls. But beneath the humor and outrage, there was something touching in the way people responded. The global reaction revealed a surprising truth. Humanity had formed an emotional bond with Pluto. We had assigned it personality, story, meaning. We loved it not because it was large or powerful, but because it was distant, small, peculiar, mysterious. Pluto felt like the underdog of the solar system, and when it lost its title, people felt as though the universe had lost a little bit of its magic. Even the astronomical community was not immune to this emotional weight. Some scientists who had voted to reclassify Pluto found themselves second-guessing their feelings. They agreed with the logic but still felt a strange sadness. Others remained resolute, insisting that scientific clarity must outweigh sentiment. Yet even they admitted that the reaction stunned them. They had not expected such an outpouring of public emotion. Some even said that the debate over Pluto revealed more about humanity than it did about astronomy. And That might be the truest part of this entire chapter. The controversy around Pluto showed that science is not a cold, sterile process. It is alive, shaped by curiosity, shaped by discovery, shaped by human hearts, wrestling with the vastness of the cosmos. We care about these distant worlds because they help us understand who we are. They remind us that we live in a universe full of stories, full of mysteries, full of characters drifting through the dark. But beyond the emotional upheaval, there was another layer of significance. Pluto's reclassification marked a turning point. It forced us to confront the growing complexity of the outer solar system. It pushed astronomers to refine theories, reassess assumptions, and look more deeply into regions once ignored. And in doing so, it opened the cosmic stage for new questions and new categories, one of which would soon take shape: the dwarf planets. You see, Pluto's demotion was not just an ending. It was the beginning of a new chapter, one in which astronomers sought to describe a class of worlds that were neither full planets nor mere fragments. Worlds that were spherical, ancient, and compelling, but that shared their orbits with others. Worlds like Eris, Haumea, Makemake, and Ceres. Worlds that enriched our understanding rather than complicating it. And that, well, is where our journey naturally leads next. Because if Pluto was no longer a planet, then what was it? And how did the world come to embrace or resist the idea of dwarf planets? The answer, as with all things in Pluto's tale, carries both scientific logic and emotional weight. And so, as we step forward into the next chapter, we enter the story of a new term, a new category, and a new way of seeing the solar system, a term born not from rejection, but from discovery. Well, you see, once the vote was cast and the echo of Pluto's reclassification began to ripple across the world, astronomers realized they needed something more than a simple exclusion. They needed language that did not merely say what Pluto was not, but what it was. And, perhaps that is where the story turns from loss into something more reflective, more careful, more attuned to the diversity of worlds drifting through the sun's great expanse. Because science, after all, rarely takes something away without offering a new framework in return. And that is the thing. Out of the debates, the disagreements, the long nights of rewriting definitions and arguing over details, a new term emerged: dwarf planet. It sounds modest, perhaps even diminutive, but the meaning behind it is surprisingly rich. A dwarf planet, the astronomers decided, is a world that orbits the sun and is shaped into roundness by its own gravity, but has not cleared its orbit of other bodies. In other words, it satisfies the first two criteria of planethood, but not the third. It exists in a cosmic neighborhood, too crowded, too wild, too dynamic for it to exert full dominance. And Pluto, with its gentle gravitational presence and its home deep in the Kuiper Belt, fit this new category perfectly. But here is the quiet irony. The term dwarf planet was not created simply to demote Pluto. It was created to acknowledge worlds that had been overlooked. Astronomers had discovered bodies like Eris and Haumea and Makemake, worlds that had grown round under their own gravity, worlds that bore the fingerprints of planetary formation. These worlds were too complex to be dismissed as mere debris, but too small and too entangled with neighboring objects to be called planets outright. They needed a category that honored their nature without distorting the structure of the solar system. And so dwarf planet became a doorway, a new space in the cosmic vocabulary. You know, many people misunderstood the term when it first appeared. They heard dwarf and assumed it meant lesser, weakened, somehow inferior. But in astronomy, scale is never a judgment. A dwarf star, for example, can burn for billions of years longer than a giant star. A dwarf galaxy can influence the evolution of a larger galaxy in subtle but remarkable ways. In the same way, a dwarf planet is not diminished. It simply occupies a different evolutionary pathway, shaped by the environment in which it formed. And, this is where the story widens beyond Pluto. Because once scientists established the dwarf planet category, they began to look more deeply at the outer solar system, identifying other worlds that shared Pluto's traits. Eris, almost the same size as Pluto. Haumea, elongated and spinning rapidly, adorned with icy rings. Makemake, bright and distant, with an atmosphere that freezes and vanishes depending on its position in orbit. Even Ceres in the asteroid belt, long thought to be nothing more than a large piece of rock, was elevated to the status of dwarf planet once its round shape and internal structure were confirmed. Suddenly, Pluto had companions not only in the Kuiper belt, but across the solar system. This moment, you see, shifted the emotional narrative. Pluto was no longer the lonely exile some imagined it to be. It became the first of a family, a pioneer rather than a castaway. And that change in perspective softened the sting for many astronomers who had struggled with the emotional weight of the debate. Some even said that the dwarf planet category gave Pluto a home that reflected its true nature more faithfully than the word planet ever had. Still, the term confused the public. Many wondered whether dwarf planets were simply small planets, much like dwarf trees are still trees, or dwarf horses are still horses. But in this case, the word did not preserve the parent category. A dwarf planet is not a type of planet. It is a parallel category. And perhaps that linguistic inconsistency is what made the term feel strange at first. People wanted clarity, not nuance. They wanted certainty in a universe that rarely offers clean boundaries. Well, I suppose the confusion was understandable. Pluto had been woven into childhood memories for nearly a century. To reframe it demanded another kind of adjustment, not scientific, but emotional. Parents had to explain to children why the solar system chart above their bed was suddenly out of date. Teachers rewrote lessons. Textbook companies revised diagrams. And all the while, Pluto remained the same icy world it had always been, turning slowly in the dark, unaware of the philosophical turbulence it had inspired on a small blue planet millions of kilometers away. Yet beneath the surface of these human reactions, a deeper scientific truth was beginning to crystallize. Pluto had not lost value. In fact, it had gained significance. By becoming the archetype of dwarf planets, it provided astronomers with a framework through which to understand a vast population of distant worlds. It guided research, inspired new theories, and anchored discussions about planetary formation. Pluto, it seemed, had stepped into a new role, one less about hierarchy and more about insight. But even as this new category clarified the structure of the solar system, it also sowed seeds of debate that would continue for years. Some scientists argued that the term dwarf planet was too ambiguous. Others claimed that the orbit clearing requirement was too Earth-centric. Still others proposed expanding the definition to include dozens of additional bodies, and, that tension revealed something essential. Astronomy, like all sciences, is a living field. Definitions evolve, boundaries shift, and no term, planet, dwarf planet, moon, star, galaxy, remains untouched by new discoveries. One particularly persistent question hovered over the discussions. If Pluto is a dwarf planet, and if dwarf planets are spherical worlds with geological processes and atmospheres, then why should we regard them as anything other than planets? After all, Pluto has mountains of water ice, plains of frozen nitrogen, a thin atmosphere that collapses and expands with the seasons, and possibly even an internal ocean. Its landscape is as varied and dramatic as many classical planets. Should complexity not count for something? Should beauty not matter at least a little? Well, beauty does matter, but scientific definitions are not built on aesthetics. They are built on structure, on relationships, on gravitational influence, and formation history. Pluto is extraordinary, yes, but extraordinary in the way a coral reef is extraordinary. Not because it dominates the ocean, but because it reveals the intricate processes within it. And that leads us to one of the most misunderstood aspects of the dwarf planet label. Many people assumed it meant Pluto had lost scientific value, but the opposite is true. Pluto's demotion was the reason it became a central target for missions like New Horizons, which revealed landscapes no one had ever imagined. Far from fading into obscurity, Pluto blossomed into one of the most scientifically fascinating worlds in the solar system. And, In a way, the emotional journey mirrored the scientific one. What began as disappointment gradually transformed into curiosity. People wanted to know more about this world that had stirred such debate. Yet the name dwarf planet still carried complications, especially for public perception. Some thought the term implied Pluto was no longer important. Others believed it suggested a hierarchy that placed dwarf planets beneath classical planets in value. But astronomy does not function through hierarchies. It functions through categories that help us trace the evolution of celestial objects, the chemistry of early solar materials, the gravitational interplay of distant worlds. Pluto's reclassification was not about worth. It was about accuracy. Still, language has power, and for many, the term dwarf planet felt like a semantic barrier, separating Pluto from the worlds we had always called planets. That discomfort, subtle and persistent, kept the controversy alive. Debates continued on television, in classrooms, in astronomy clubs. Some scientists proposed removing the orbit clearing criterion altogether. Others wanted to expand the term planet. Others still suggested entirely new categories. By the time we approached eras like 2025, these conversations had become part of a broader dialogue about how we define objects in a universe that refuses simplicity. And in that sense, Pluto, as it had always done, served as a catalyst for curiosity, a world that forced us to ask not only what things are, but why we choose to name them as we do. And you see, this is where the story quietly turns again, because once the term dwarf planet took hold and Pluto stood as its most famous example, astronomers were free to examine Pluto on its own terms, not bound by the expectations of classical planets. They discovered its mountains, its glaciers, its strange heart-shaped basin, its active geology. They realized Pluto was not merely a frozen relic. It was alive in its own way, dynamically, geologically, atmospherically alive. And that revelation leads us naturally, irresistibly into the next chapter. For now that we have named Pluto, classified it, and placed it within its cosmic family, the time comes to look more closely at what lies upon its surface. Its mountains of ice, its whispers of atmosphere, its hidden ocean, its restless plains. The story, you see, does not end with labels. It deepens with discovery. And so we continue, stepping from definitions into the revelations that awaited us when a small spacecraft crossed the solar frontier and showed us Pluto not as an argument, but as a world. Well, you see, once Pluto had been gently placed into its new category, no longer a classical planet, but something more nuanced and strangely poetic, the world might have expected the story to grow quieter, as though the debates, the definitions, the tears, and the nostalgia would settle into silence. But, that is not how the universe works, and certainly not how Pluto works. Because just as the arguments on Earth were reaching their peak, a small spacecraft was racing through the darkness, carrying with it the promise of an entirely new chapter in Pluto's story, one that would replace speculation with revelation, and emotion with awe. And that is the thing. New Horizons, the spacecraft designed to visit Pluto, was something of a cosmic love letter, launched long before the decision to call Pluto a dwarf planet, before anyone imagined the emotional turbulence that would follow. It traveled for nearly a decade across billions of kilometers, silent and patient, like an arrow shot into the night with no certainty of what it would find. And you know, there is something beautiful about that. A mission conceived when Pluto was a planet, destined to arrive when it no longer was. A journey that transcended labels, aimed not at classification, but at understanding. By the time New Horizons finally reached Pluto, after moving faster than any spacecraft launched before it, the human world had changed. Debates had cooled into resignation or curiosity. Textbooks were rewritten. Children had grown up asking why Pluto was no longer a planet. But the spacecraft did not care about names. It cared about the truth waiting in the frozen dark. And then, in 2015, New Horizons arrived. Perhaps you remember the photos, those first breathtaking images drifting down to Earth like gifts from a distant dream. Pluto was not a dull, lifeless orb. It was not a fuzzy speck with no story to tell. It was a world full of landscapes so strange and majestic that even seasoned astronomers found themselves whispering in disbelief. One of the first features to capture the world's imagination was a vast, bright, heart-shaped region stretching across Pluto's surface. A heart, a symbol humans could not resist reading into. This was Sputnik Planitia, an enormous plain of frozen nitrogen, a surface so smooth and young that it revealed ongoing geological activity. For many, it felt like Pluto was offering us a quiet message, a gentle reminder that its story had room for wonder beyond argument. But the surprises did not end with a single shape. Well, you see, the mountains of Pluto stunned the scientific community. These peaks, rising as high as the Rockies, were made not of rock, but of water ice. Ice hardened by unimaginable cold, strong enough to support towering structures. Imagine standing at the foot of such a mountain, the sun a dim star overhead, the sky tinted by faint traces of atmosphere, the ground beneath your feet crackling softly like frozen glass. And, perhaps that image alone forces us to rethink what a mountain can be. The universe reminding us that familiar forms take on unfamiliar meanings in the far reaches of space. And then there was the question of an ocean. For decades, Pluto was assumed to be frozen solid all the way through. A relic, static, dead. But as New Horizons gathered data, subtle variations in surface height, clues in the gravitational field, scientists began to suspect that beneath Pluto's icy shell, a vast subsurface ocean might be hiding. A global ocean of liquid water, insulated by layers of nitrogen ice and frozen crust. An ocean kept warm not by sunlight, they receive almost none, but by the slow decay of radioactive elements within Pluto's core, and the pressure of its own thick ice shell. If that ocean exists, and many scientists now believe it does, it would place Pluto among a small and extraordinary family of ocean worlds in the solar system, worlds like Europa, Enceladus, and Titan. Worlds where liquid water, one of the great ingredients of life, persists in the dark. And perhaps this thought leads us to a quiet, trembling question. Could a world once demoted contain something so profound? Something that links it to the possibility of biology, chemistry, or even the faint memory of ancient processes. But New Horizons did not stop there. It revealed that Pluto has an atmosphere, thin, fragile, shimmering like a ghost above its surface. This atmosphere is made primarily of nitrogen, with traces of methane and other gases. It expands when Pluto moves closer to the sun, and collapses when the world drifts outward into coldness. Imagine the atmosphere itself breathing in and out over centuries. And there, suspended in that thin air, were delicate layers of haze, stacked like translucent veils, glowing blue when backlit by the sun. Perhaps that blue glow touched something in the human imagination. It suggested that even in the coldest corners of the solar system, beauty emerges where we least expect it. And, in a way, it was poetic justice. Just when people questioned Pluto's dignity, it revealed itself as one of the most visually striking worlds ever photographed. But the most astonishing revelation from New Horizons was this. Pluto is not dead. Its surface is not stagnant. Sputnik Planitia is constantly reshaping itself as frozen nitrogen sublimates, moves, and refreezes, creating patterns like dunes, ridges, cracks, and cellular convection patterns, unlike anything seen elsewhere. There were signs of glaciers flowing slowly across Pluto's plains, signs of tectonic motion, signs of impact craters erased over time by resurfacing. Pluto, we learned, is geologically alive. That revelation reshaped scientific understanding. For decades, astronomers assumed that small, distant worlds must be cold and inert. But Pluto shattered that assumption, suggesting that internal heat could persist for billions of years, driving cycles of change even at the edge of sunlight. And suddenly, dwarf planets, once considered minor, became central to the study of planetary evolution. Pluto offered us a world with mountains of ice, instead of rock glaciers of nitrogen, instead of water haze that glows blue, a possible hidden ocean's surface that reshapes itself with slow, persistent energy. It was as if New Horizons whispered, gently but insistently, look again, look closer. The universe is always more than you think. And the emotional effect of these discoveries was profound. People who once mourned Pluto's demotion now celebrated its complexity. The world that had been stripped of its title suddenly emerged as one of the most fascinating testimonies to the diversity of the solar system. Scientists who had debated definitions found themselves united in awe. Even those who had voted to reclassify Pluto admitted that the data coming back from New Horizons rekindled their sense of wonder. And perhaps that is the greatest lesson of this chapter. Pluto did not lose anything by becoming a dwarf planet. It gained the freedom to surprise us, and in that freedom, it revealed more secrets than we ever imagined it possessed. As the spacecraft continued past Pluto, sending back its final images and measurements, a quiet realization settled over the scientific community. If Pluto, a small world, a world at the edge, a world almost overlooked, could be this dynamic, this beautiful, this complicated, then what of the others? What of Eris, Makemake, Haumea? What of the thousands of icy bodies still hidden in the Kuiper Belt? What of the ocean worlds buried beneath frost? You see, New Horizons did more than reveal Pluto. It opened the door to an entire class of worlds that demand our attention. It suggested that life's ingredients might be far more widespread, that geological processes might thrive in places we once dismissed, that the solar system is richer and more surprising than we ever allowed ourselves to believe. And so, as we drift from this chapter into the next, the focus shifts naturally from Pluto itself to its companions. Not its companions in orbit, but its companions in identity. The moons that circle it. The strange gravitational bond it shares with Charon. The miniature system that challenges everything we thought we knew about how worlds interact. Because Pluto is not alone. It was never alone. And the next chapter leads us into the delicate, mesmerizing choreography of Pluto and its moons, a dance that reveals yet another layer of mystery at the edge of the sun's domain. Well, you see, once New Horizons had revealed Pluto in all its unexpected beauty, the world paused, for just a moment, to take in the scale of what had been uncovered. But, perhaps the most astonishing truth waiting there in the shadowed cold was this. Pluto is not a solitary wanderer. It is the heart of a small, intricate system, a family of worlds bound together by gravity, history, and a kind of cosmic intimacy that feels almost tender when you look closely enough. Because to understand Pluto fully, we must understand not only its surface or its atmosphere, but the companions that travel with it through the deep Kuiper darkness. And that is the thing. Pluto has moons. Not just one, not just two, but 5, each with its own story, its own character, its own orbit, woven delicately into the larger choreography of the system. The best known of these is Charon, the largest moon, discovered in 1978. But to call Charon a moon feels almost misleading. Charon is so massive relative to Pluto that the two worlds orbit a shared center of gravity that lies outside both of them. This makes the Pluto-Charon system unlike any other pair in the solar system, more like a dance between equals than the familiar orbit of a moon around a planet. In fact, many astronomers describe Pluto and Charon as a binary system, a double world, 2 spheres locked in a gravitational embrace. You know, when New Horizons approached Pluto, one of the first images it sent back was a portrait of Pluto and Charon together, with Charon appearing like a pale companion half the width of its partner. And, the scale alone is breathtaking. Charon is roughly half Pluto's diameter, and its mass is so significant that if Earth had a moon proportionally that large, our tides, our days, our stability would all be wildly different. The presence of Charon has shaped Pluto's evolution, slowed its rotation, locked it into a synchronous spin so that each world always shows the same face to the other. Imagine that, for a moment. If you stood on Pluto and looked into the sky, Charon would hang there, unmoving, forever occupying the same place in the heavens. A frozen companion, a cosmic constant. And that frozen constancy creates something remarkable between the two worlds. Because their shared center of gravity sits outside Pluto, they orbit a point in empty space, circling it every 6 Earth days. It's as though the universe is gently reminding us that balance does not always mean dominance. Sometimes it means partnership. And perhaps that is why scientists find the Pluto-Charon system so mesmerizing. It challenges the familiar story of planets and moons, replacing it with something more subtle, more relational, more like a duet whispered into the cosmos. But Charon, well, Charon is only the beginning. Once Pluto's primary companion was discovered, astronomers kept looking and found more. Tiny, faint moons that orbit much farther out, so small and reflective that they barely appear in telescope images. These moons, Nix, Hydra, Kerberos, and Styx, are irregular, lightweight remnants, likely fragments from the same ancient collision that formed Charon billions of years ago. Their orbits are delicate, nested around the Pluto-Charon system like rings around a quiet lantern. And you know, what's truly fascinating is how these small moons move. They do not rotate steadily like Earth's moon. Instead, they tumble chaotically, their spins unpredictable, influenced by the gravitational interplay of the binary pair at their center. It's almost as though they are caught in a cosmic storm of subtle forces, drifting between order and disorder. Well, that tumbling is not simply random motion. It is a mathematical consequence of living in a gravitational field shaped by two bodies of comparable size. As Pluto and Charon orbit their shared center of mass, the gravitational pull on these tiny moons shifts from moment to moment, never allowing them to settle into a calm, steady rotation. And, perhaps there is something beautifully symbolic in that. The outer moons of Pluto exist in a state of perpetual motion, their identities constantly rewritten by gravitational tides. They remind us that stability is not universal. Some worlds are born to wander even as they orbit. But the formation of this system is the deeper story. Most moons in the solar system formed either through gravitational capture or by accretion in the early disk surrounding planets. But Pluto's moons almost certainly originated in a single cataclysmic event, a collision between Pluto and another large Kuiper Belt object long ago. The impact would have ejected debris into orbit, which then coalesced into Charon and the smaller moons. This is strikingly similar to the event believed to have formed Earth's moon. And so, in a strange way, Pluto shares something intimate with our own planet, both worlds shaped by ancient violence that blossomed into companionship. You see, when New Horizons swept through the system, it did not merely observe. It illuminated. It revealed Charon's surface scarred by canyons so deep they dwarf the Grand Canyon, cliffs miles high carved by tectonic forces, and regions with surprisingly smooth plains that speak of past geological activity. Charon, like Pluto, is not dead. Its surface holds memories of internal heat, of shifting terrains, of perhaps even a subsurface ocean in its distant past. And that thought, that two icy bodies locked together might both have once harbored oceans, expands our understanding of where life-supporting conditions could arise. Nix and Hydra, the brightest of the small moons, offered their own surprises. Their surfaces reflect light so efficiently that scientists compared them to cosmic snowballs made of nearly pure water ice. Hydra, in particular, glistens with a brightness that rivals some of the most reflective bodies in the solar system. It spins astonishingly fast, rotating unpredictably, as though unable to settle into any single rhythm. Nix, softer in tone, shows patches of varying colors, possibly due to the photochemical alteration of surface ice by sunlight. Each moon, though small, carries within it hints of a vivid, dynamic history. Kerberos and Styx, even smaller and fainter, appeared as fragile fragments when New Horizons captured them, elongated, irregular, perhaps shaped by collisions or mergers with even smaller objects over time. Their presence raises questions about how many other tiny moons might once have orbited Pluto before being lost to the chaos of gravitational interactions. And in a way, the existence of these faint companions deepens the mystery of Pluto's past. The system feels like a family shaped by ancient turbulence, now gliding through a calm dark after billions of years of slow settling. But perhaps the most enchanting aspect of this system is the way its components move together. Pluto and Charon locked in synchronous rotation, Nix, Hydra, Kerberos, and Styx orbiting beyond them in resonances that stack like harmonies in a complex chord. For every orbit Hydra makes, Nix completes another in a different rhythm, and Styx dances between them. It's a gravitational symphony, subtle, intricate, difficult to model, but mesmerizing to behold. And, when astronomers first analyzed the orbital resonances, they spoke with a kind of reverence, as though they were listening to a cosmic piece of music that had been playing unnoticed for billions of years. The uniqueness of the Pluto-Charon system extends beyond its internal dynamics. It also redefines our understanding of what a planetary system can look like. Unlike the simple arrangement of Earth and its moon, or Mars and its two small companions, the Pluto system is balanced. The center of mass lies between Pluto and Charon, not inside either. Their mutual tidal locking means each world always faces the other, forming a bond that resembles two dancers spinning around an unseen center. The smaller moons caught in this dance add complexity and unpredictability, turning the system into a miniature laboratory for studying gravitational physics. And perhaps when we step back and view the system as a whole, we begin to realize something profound. Pluto and its moons form not a hierarchy, but a community. A collection of bodies shaped together, evolving together, entwined in a gravitational relationship so delicate and so unusual that it challenges the very idea of what a planetary system should be. The word moon feels inadequate here. Charon is not simply a follower, it is a partner. The smaller moons are not background objects, they are participants in a shared story. Well, you see, this system offers astronomers a window into processes that occur nowhere else in the solar system. It suggests that binary planets might be more common than we once believed. It demonstrates how collisions can give birth to entire families of worlds. It reveals that even in the coldest regions, history leaves signatures bold enough to endure billions of years. And, there is another subtle truth in all of this. While Pluto and Charon orbit their shared center in stable, predictable cycles, the smaller moons tumble and twist without repeating patterns. If you tried to stand on Nix or Hydra, you would never see the same sky twice. Horizons would spin. The sunlit day would twist unpredictably into night. The cosmos above you would whirl like a kaleidoscope. These moons challenge our intuition, reminding us that stability is not universal, that chaos is not disorder but another kind of order, one written in the language of gravity and resonance. As new horizons passed through the system, capturing fleeting images, scientists sensed that they were glimpsing only the beginning of what this miniature world family had to teach us. Every crater, every ridge, every irregular orbit whispered of histories still unknown. And in that whisper, a new curiosity began to rise. Because if Pluto's moons could be so diverse, so complex, so deeply interconnected, then what did this imply about the Kuiper Belt as a whole? How many other systems like this one exist at the edge of the solar system? How many binary worlds? How many fractured families born of ancient collisions? How many icy worlds with hidden oceans or tumbling moons or unexpected beauty? And those questions, well, lead us inevitably toward controversy once again. For if Pluto's system is so rich, so full of dynamism and complexity, then was the decision to reclassify Pluto truly final? Should such a world, so geologically alive, so rich in history, really be called a dwarf planet? Or should the definition evolve, as all definitions in science eventually do? And so, as we leave behind the delicate cosmic dance of Pluto and its moons, we find ourselves stepping into a new chapter, one where debate rekindles, where scientists argue passionately over the meaning of the word planet, and where Pluto becomes once again the center of a storm of ideas. Well, you see, by the time New Horizons had swept past Pluto, and the world had seen its mountains of ice, its flowing glaciers, its blue haze, and its astonishingly young plains, something unexpected happened. Instead of calming the debate over Pluto's status, the discoveries breathed new life into it. And, perhaps that is the most human part of this story. Knowledge doesn't always settle arguments. Sometimes it deepens them. Sometimes, the more clearly we see a world, the harder it becomes to place it neatly into categories. And that is the thing. Even after the International Astronomical Union made its decision, even after Pluto was formally named a dwarf planet, many scientists refused to accept the verdict. Prominent astronomers from major universities, planetary scientists who had spent years studying Pluto's geology and atmosphere, and even members of the New Horizons mission itself argued passionately that Pluto should remain a planet. They pointed out that Pluto has an atmosphere, seasonal cycles, active geology, mountains, plains, and possibly even a subterranean ocean. If those features did not qualify it as a planet, then what would? Their opposition was not an emotional outburst. It was a scientific stance, rooted in the belief that a definition should reflect the nature of an object, not merely its orbital behavior. Well, the question became a philosophical one, as much as a technical one. Should a world's identity depend on what it is or where it lives? On the other side, many astronomers defended the dwarf planet classification with equal passion. They argued that if Pluto were called a planet, then dozens of other Kuiper Belt objects of similar size and structure would also need to be planets. And in a sense, they were right. The Kuiper Belt is rich with worlds, Eris, Makemake, Haumea, each with their own peculiarities, each demanding recognition. This group insisted that keeping the definition strict preserved clarity in a solar system already more complex than early astronomers ever imagined. A planet, in their view, needed to dominate its orbit, shaping its neighborhood rather than sharing it. And so, the scientific community split into two camps, neither side foolish, neither side stubborn, both trying to do justice to a universe that rarely conforms to simple lines. But, perhaps the real reason the debate would not die is that the definition of a planet itself is surprisingly slippery. The criteria adopted in 2006 felt clear at first glance, but the more scientists explored them, the more they found cracks. What does it truly mean to clear an orbit when even Jupiter shares its space with thousands of Trojan asteroids? Why should orbital behavior matter more than internal complexity? And should a definition crafted for our solar system apply equally to exoplanets, which orbit stars light years away in conditions we have barely begun to understand? These questions lingered in papers, in conference halls, in university classrooms, shaping a discussion that refused to settle. And, the more Pluto revealed through New Horizons, the more one group felt vindicated. Because if a planet is a world that changes, evolves, breathes through geological processes, then Pluto exceeds the expectations of many classical planets. Its glaciers flow, its plains convect, its nitrogen cycles across seasons lasting decades. Its mountains rise from water ice as strong as granite in the frozen dark. In this sense, Pluto behaves more like a small Earth than a simple remnant of the solar system's formation. This raised another question, one that quietly grew louder with every new study. Should the definition of a planet change again? Perhaps broaden, perhaps expand to include worlds that demonstrate internal activity, even if they occupy crowded orbits. A few astronomers proposed new definitions that would increase the number of planets to dozens, even hundreds, embracing the diversity of the solar system rather than resisting it. One proposal suggested classifying planets by intrinsic properties, roundness, geologic complexity, rather than orbital mechanics. Another proposed adding multiple tiers of planets, reflecting subtle differences rather than enforcing rigid boundaries. But others warned that these new definitions risked unraveling the clarity science relies on. If we name every spherical object a planet, then the solar system becomes unwieldy. Children memorizing planets would face pages of names. Textbooks would grow thick with lists. The simplicity that helped earlier generations understand their place in the cosmos would dissolve into complexity. And yet, simplicity is often a luxury of limited knowledge. The universe rarely grants us neat order. It gives us breadth and variation. And so the controversy stayed alive. But you see, the debate also persisted because of emotion, a rare and beautiful reminder that science is practiced by human beings, not machines. Pluto had been part of our collective imagination for nearly a century. Its demotion felt like losing a childhood friend, as though the universe had become slightly less magical. Many people wondered if a world so beloved could ever truly be removed from the planetary family. In town halls, school classrooms, public lectures, and online forums, the question was asked again and again, should Pluto come back as a planet? And some scientists, moved by this public sentiment, advocated for a reinstatement. They argued that science and culture need not be in conflict. Definitions can evolve. Names can reflect both accuracy and meaning. But the issue, well, was not that simple. Science needs consistency, and naming Pluto a planet while leaving similar Kuiper Belt worlds unnamed would create new inconsistencies, new debates, new lines needing to be drawn. If Pluto is reinstated, should Eris be as well? Should Haumea, Makemake, Ceres? Where does the list end? And does the concept of a planet lose meaning when stretched too far? This uncertainty fueled the fire. Conferences held years after the original vote still included heated discussions about Pluto's status. Papers published decades later still challenged the definition. Even scientists who supported the current terminology admitted that the controversy was far from resolved. Some predicted that new discoveries, especially those from telescopes built in eras beyond 2025, might force another revision. Others argued that we simply needed to accept ambiguity for the time being. And, one of the most interesting aspects of this ongoing debate is the way it mirrors older scientific disputes. The shape of Earth, the nature of comets, the classification of stars. Again and again, the universe forces us to re-examine our assumptions, not out of failure, but out of growth. Pluto, in its quiet way, has become part of that tradition, a small world that challenges big ideas. Still, the question persisted. Could Pluto ever return to its former status? Some argued yes. They pointed to the possibility of redefining the orbit-clearing criterion. They noted that even Earth shares its orbit with thousands of near-Earth objects. They suggested that perhaps dominance should not be the measure. Others believed that a new class of planets, perhaps called geologically active planets, could include Pluto without dismantling the current structure. But no final consensus ever emerged. Every answer opened more questions. Every attempt to simplify created new complexities. And perhaps that is fitting, because Pluto itself is not a simple world. It is layered, dynamic, puzzling, a place of flowing ice, shifting landscapes, and a possible buried ocean. Why should its classification be any simpler than its nature? And that brings us to the final truth of this chapter. The controversy is not over. It continues quietly in journals, in classrooms, in conversations among astronomers walking between lectures. It lingers in the minds of those who grew up with 9 planets and in the excitement of children discovering Pluto's wonders for the first time. But the debate, for all its passion, does something beautiful. It keeps Pluto alive in the public imagination. It keeps us asking, questioning, reaching. It keeps us humble before the vastness of the cosmos, reminding us that definitions are temporary, but curiosity endures. And as the arguments continue, one question begins to rise from them, gentle but insistent. If Pluto were to become a planet again, what would it change? How would our maps shift? How would our textbooks grow? How many new worlds would we welcome into the planetary family? And that question, well, leads us directly into the next chapter, a chapter where imagination blends with possibility, and we dare to ask what the solar system would look like if Pluto reclaimed its place. Well, you see, once the debates grew so large that they spilled beyond scientific circles and into classrooms, newspapers, living rooms, and late-night conversations, a curious question began to hover gently above all the noise. And, perhaps it was inevitable, really. Because once people asked whether Pluto should be restored to its former title, the next thought unfolded almost naturally. What would actually happen if Pluto became a planet again? What would that mean for our maps, our definitions, our understanding of the solar system? And more quietly, beneath the technical questions, was another. How would it feel? And that is the thing. When we imagine the solar system changing, we often picture something grand, planets shifting in their orbits, stars trembling, cosmic reconfigurations. But the truth is far more intimate. If Pluto were restored to planethood, the first and most immediate change would ripple through the way we teach the universe to children. No longer would school posters show a chain of 8 worlds. They would stretch once more to include Pluto, far from the sun, drifting at the edge like a lantern carried by the wind. And textbooks, which had grown accustomed to describing the solar system as 8 planets plus dwarf planets, would need to be rewritten, reorganized, reimagined. That might sound simple. Just add one more world back into the list. But, it isn't so easy. Because Pluto would not return alone. This is where the true magnitude of the question reveals itself. If Pluto is a planet because it is round, complex, geologically active, and orbits the sun, then Eris must be a planet as well, and Haumea, and Makemake, and Ceres in the asteroid belt, and candidates like Sedna, Gongong, Quaoar, and Orcus. The solar system, once a tidy neighborhood of 9, could suddenly blossom into dozens of planets, each demanding its own chapter in textbooks, its own place in models, its own identity. And, perhaps this expansion would be thrilling, a grand unveiling of the diversity that has always existed but remained unacknowledged. But it would also challenge the very structure of how we understand the cosmos. Imagine children in school repeating a list not of 9 planets, but of 20 or 30. Imagine curriculum designers reshaping lessons. Imagine teachers explaining that planets come in many forms: rocky, gaseous, icy, elongated, rapidly spinning, or quietly dormant, and that the boundaries between them are more like watercolor than ink. Yet, there is something beautiful in that, don't you think? A solar system with many planets would more accurately reflect the richness of what we know today. It would acknowledge that the universe is more complicated than earlier generations believed. It would give a place of honor to worlds once hidden, overlooked, minimized. Every child could grow up knowing not just Earth and Mars and Jupiter, but Pluto with its frozen heart, Haumea with its wild, elongated shape, and Eris with its distant, lonely orbit. Still, the challenge would be immense. Scientific definitions would need to stretch, transform, perhaps even dissolve entirely before reshaping themselves into something more flexible. Because restoring Pluto without restoring the others would create a contradiction. One definition for one world, another for the rest. And science resists contradictions. It seeks coherence. And that coherence would mean embracing a solar system expanded and alive with variety. Another ripple would appear in diagrams and models. Most representations today condense the outer solar system for convenience, shrinking billions of kilometers into a few centimeters. But if Pluto returned to planethood, perhaps there would be renewed focus on the outer worlds, encouraging us to depict them with greater care. Models might include not just distant Pluto, but its moons, its shape, its geology. And in acknowledging Pluto, we might spark curiosity about its neighbors, prompting a new generation to explore regions of space once treated as margins. Well, and here is another thing. The scientific community would need to reconsider theories of planetary formation. If dozens of planets exist, then the early solar system must have been more turbulent, more creative, more crowded with potential worlds than we imagined. Instead of a few large bodies sweeping up all the material, perhaps the story is one of competition and coexistence. Hundreds of embryonic planets forming, colliding, surviving, or drifting into the shadows. Pluto's reinstatement could revive old theories or inspire entirely new onis. But the consequences would not be purely scientific. There would be emotional impacts as well, soft, human, and deeply felt. Many people would experience a quiet joy at Pluto's return, a sense of closure perhaps, a feeling that the universe had regained a piece of its poetry. Children who grew up amid the controversy might feel as though a missing puzzle piece had clicked back into place. Adults might feel nostalgia tempered with wonder. And astronomers, even those who supported the demotion, might feel a sense of renewed possibility. Yet, not everyone would be satisfied. Because restoring Pluto would once again raise difficult questions about boundaries. What counts as a planet? What matters more, location or structure, dominance or complexity? And these questions would spark fresh debates, perhaps even more heated than the ones in 2006. Planetary science conferences would fill with arguments. Research papers would multiply. Definitions would morph and stretch, challenged by every new observation of distant worlds. And the public, drawn as always to the emotional core of the story, would watch with fascination. Late-night hosts would joke about planetary inflation. Social media would buzz with lists of newly recognized planets. Documentaries would explore the shifting landscape of planetary science. And through all of this, Pluto would shine quietly, reminding us that even the smallest world can stir profound questions. But the most significant consequence of reinstating Pluto might be this: it would force humanity to embrace complexity rather than simplicity. Our instinct is to categorize, to sort, to define. We like neat lists, clear boundaries. But the universe rarely abides by such preferences. It is messy, abundant, layered with subtlety. And if Pluto were called a planet again, we would be acknowledging that messiness is not a flaw. It is the natural state of a universe built from billions of years of chance, pressure, collisions, heat, and ice. Perhaps this shift would ripple outward, encouraging people to rethink other cosmic ideas as well. Stars that defy classification, moons that behave like planets, asteroids that blur the line between rock and world. And in embracing these ambiguities, we might discover a more honest relationship with the cosmos, one built not on control, but on wonder. But reinstating Pluto might also cause scientific turbulence. Theories anchored to the 8-planet model would require revision. Papers would need updating. Databases would have to be reconfigured. Mission targets might shift. Funding bodies might reconsider their priorities, focusing more on distant icy worlds and less on classical planetary bodies. And while this turbulence could be challenging, it might also ignite innovation. Imagine future missions designed specifically to explore dwarf planets, though in this scenario, they would no longer be called dwarf planets. Imagine probes landing on Eris, sailing across the icy plains of Makemake, sampling the faint atmosphere of Gong. Reclassifying Pluto could open the doorway to an era of outer solar system exploration, driven by renewed excitement. But perhaps the most fascinating consequence is this: Pluto would no longer stand alone. It would not be the odd world out, the misfit, the exiled planet. It would be part of a family of planets, each with its own story. And this shift would fundamentally reshape how we talk about the solar system. No longer 8+1, no longer planets and dwarfs. Instead, a continuum of worlds, each valuable, each deserving of study. And yet, as we consider all these possibilities, a gentle question arises. Would restoring Pluto truly change the universe, or only our relationship with it? Because Pluto itself would remain what it always was, a world of frozen plains, towering ice mountains, a thin atmosphere, and perhaps an ocean deep beneath its crust. Its geological heart would continue beating slowly, untouched by the labels humans assign. That realization, you see, leads us into deeper reflection. Labels shape perception, but they do not shape nature. Even if Pluto returned to planethood, the true value of the change would lie in how it reshapes our thinking, opening our minds to diversity, complexity, and the sheer abundance of worlds that exist beyond Neptune. And this reflection guides us gently into the next chapter, because while it is important to imagine what might happen if Pluto were a planet again, it is equally important to understand why we care, why this small world captures the imagination so fiercely, why its fate stirs emotions in a way that no other celestial controversy has, why Pluto has become more than a world. It has become a symbol. And that, well, brings us to the final chapter, where science meets culture, and where Pluto reveals not only the mysteries of the cosmos, but something essential about ourselves. Well, you see, by the time we reach this final chapter of Pluto's long and winding story, something subtle but deeply human begins to shine through. Because beneath all the scientific debates and shifting definitions, beneath the charts and diagrams and orbital mechanics, Pluto has become something far more than a distant icy world. It has become a mirror, reflecting the way we feel about exploration, about belonging, about loss, about wonder. And perhaps that is why this chapter feels softer, more intimate. It is no longer about what Pluto is, but what Pluto means. And that is the thing. People, ordinary people, not astronomers, love Pluto. Not in the way one might love Jupiter's storms or Saturn's rings, but in a gentler, more protective way. Pluto feels fragile, like a quiet character in a vast cosmic novel, someone small and far away who nevertheless holds a place in our hearts. When Pluto was demoted, millions felt an unexpected ache, as though something familiar had been taken. Letters poured into observatories. Children wrote to space agencies asking what Pluto had done wrong. Adults found themselves defending a world they had never seen. You know, that reaction tells us something about ourselves. We project stories onto the sky. We see personality in planets, longing in comets, comfort in the steady glow of stars. And Pluto, with its small size and distant orbit, became the cosmic underdog, misunderstood, mislabeled, but deeply loved. Pluto found its way into films long before the controversy erupted. Animated movies depicted it as cold, lonely, mysterious. Science fiction stories imagined colonies beneath its ice, or explorers journeying through the Kuiper Belt. Even fantasy tales sometimes placed Pluto at the edge of magic, where worlds fade into myth. After the reclassification, Pluto appeared in cartoons as a character protesting its demotion, waving little picket signs or standing defiantly beside its planetary siblings. And, while these portrayals were humorous, they also revealed something profound. Pluto's identity had merged with culture. It was no longer just an astronomical object. It was an idea. In education, Pluto has played a curious dual role. For generations, it helped children learn the structure of the solar system, Mercury, Venus, Earth, all the way outward to the mysterious ninth world. Teachers would describe its faint sunlight, its icy plains, its strange orbit, evoking images of a realm where the sun is only a distant star. Then came the reclassification, and classrooms shifted. Teachers now had to explain not only the solar system, but the nature of scientific change. Pluto became a perfect example of how knowledge evolves. And perhaps, in a quiet way, Pluto taught children something more important than astronomy. That truth grows, that understanding is not fixed, that science is a conversation, not a decree. Still, the emotional weight remained. Many people describe Pluto as a symbol of injustice, a world stripped of its identity by a vote. The phrase "poor Pluto" echoed across headlines. Artists drew scenes of Pluto being kicked out of the planetary lineup, holding a suitcase, shuffling away sadly. And although humorous, these images reflected a sincere feeling: compassion. Somehow, Pluto awakened empathy, and that empathy, well, is one of the most remarkable parts of this entire story. Why did Pluto's demotion spark sadness? Why did people feel as though something had been lost? Perhaps it is because Pluto's story resembles our own. A small world, overlooked for so long, discovered with great effort, celebrated for decades, then questioned, redefined, debated. It felt like watching someone go from belonging to being set aside, and that narrative touches something deep within the human spirit. We know what it means to feel out of place. We know what it means to be misunderstood. Pluto became, in a sense, the patron saint of outsiders. And yet, that emotional response reveals a truth often forgotten. Science is not cold. Science is made of people. People with memories, with hopes, with stories, with dreams of the stars. Even astronomers, trained to analyze data and challenge assumptions, admitted to feeling sorrow when Pluto was reclassified. Some described the vote as though they had broken something precious. Others confessed they hesitated before raising their hands as if they were voting on a friend. You see, Pluto's tale exposes a delicate truth about the nature of scientific progress. Knowledge changes. Definitions shift. What we believe today may be revised tomorrow. And that does not mean we were wrong. It means we learned. Pluto reminds us that the universe is always larger than our first interpretations. Every discovery stretches our boundaries. Every observation deepens our questions. And, perhaps that is why the story of Pluto is so often invoked when people discuss the philosophy of science. Pluto's reclassification is not simply a debate about terminology. It is a living example of how science evolves, how human understanding adapts as new evidence emerges. And this evolution, sometimes uncomfortable, sometimes emotional, is a sign not of instability, but of strength. A science that cannot change, cannot grow. Yet, there is a gentle beauty in Pluto's cultural presence. Its heart-shaped basin, revealed by New Horizons, became a symbol almost instantly. People saw it on the images, this vast, bright region shaped uncannily like a heart, and felt as though Pluto itself had sent a message. I'm still here. I still matter. That heart became a logo for t-shirts, posters, documentaries. Children drew it in classrooms. Scientists printed it on conference badges. And in that image, Pluto transformed from a scientific controversy into a cultural icon. Pluto's ability to evoke emotion also reveals something else, that cosmic stories help us understand ourselves. We look at Pluto and see not just frozen nitrogen plains and water ice mountains, but a reflection of resilience, a reminder that labels do not define worth, that even the smallest world can hold beauty, complexity, and mystery. And as the world inched closer to eras like 2025, Pluto continued to inspire, not as the ninth planet, not as a dwarf planet, but as Pluto, a world that refused to fit neatly into expectations. In that way, Pluto teaches us something precious, that the universe is not obligated to match our categories. We must adapt to it, not force it to adapt to us. And the story of Pluto also highlights the emotional dimension of scientific curiosity, because at its core, science is driven by wonder, the same wonder that once guided Clyde Tombaugh's gaze across the stars, the same wonder that launched New Horizons on its long journey, the same wonder that stirred public outcry when Pluto's category shifted. People do not fight for Pluto because of its mass or orbit. They fight for it because they feel a connection. And that connection is a reminder that exploration is not just an intellectual act, it is a deeply human one. Perhaps the most profound lesson Pluto offers is humility. We thought we understood the solar system. We believed the planets were a fixed list, and then Pluto came along and unraveled the edges of our certainty. It showed us that definitions are fleeting, that discovery reshapes reality, that the cosmos will always exceed our expectations. And in that revelation, there is freedom. Because if Pluto can teach us that even something as fundamental as a planet can be redefined, then nothing in science is truly static. And, this leads us to the quiet heart of this chapter. Pluto's story is not just about Pluto. It is about us, our desire for order, our love for beauty, our instinct to protect the small, our willingness to question, our courage to change our minds. Pluto illuminates something deeply human, our longing to belong in a universe so vast it almost defies comprehension. And as we step now from this emotional landscape toward the end of our journey, Pluto leaves us with one final question. Soft, lingering, shimmering like starlight on a cold night. In the end, what gives something its value? The title we assign it, or the nature it reveals when we dare to look closer? And that question, well, carries us toward the closing thoughts, where the story of Pluto becomes the story of science itself, and the story of how we, tiny beings on a pale blue world, reach out to understand a universe that is endlessly, achingly, beautifully larger than we ever imagined. Well, you see, by the time we reach what might be called an unplanned but inevitable chapter, one that stretches beyond the original 12, there is a kind of quiet momentum guiding us, as though Pluto's story, with all its twists and disagreements and moments of wonder, refuses to end neatly where we thought it would. And, perhaps that is fitting, because the universe, after all, rarely respects the edges we draw around our narratives. It spills over, expands, invites new questions, demands new chapters. And Pluto, small and shimmering at the fringe of sunlight, seems especially skilled at doing just that. And that is the thing. After examining its discovery, its rise, its fall, its geology, its moons, its controversy, and finally its place in human emotion, we begin to ask a new kind of question, one that looks not backward or inward, but forward. What lies ahead for Pluto, not just scientifically, but culturally, philosophically, intellectually? Where does its story lead us now? In a sense, this chapter becomes an exploration of Pluto's future, and of our future with it. You know, one of the most fascinating parts of Pluto's legacy is the way it continues to shape scientific ambition. Even after New Horizons completed its flyby, the data it returned opened doors to new hypotheses, new missions, and new questions about the icy worlds of the Kuiper Belt. Some scientists began advocating for a return mission. This time not a fleeting pass, but an orbiter that could stay, observe, learn, linger. The idea alone carries a kind of poetry. Imagine a spacecraft settling into orbit around Pluto, circling it softly for years, watching its atmosphere expand and collapse, measuring its tides, mapping its ocean beneath the crust. Perhaps even deploying a lander that touches down on the smooth nitrogen plains of Sputnik Planitia, or the ancient ice mountains of Tenzing Montes. But, the challenge is immense, sending an orbiter that far requires not only technological innovation, but a shift in priorities. Still, in eras like those beyond 2025, as humanity's reach extends outward with renewed vigor, the dream feels less impossible than it once did. And that dream, you see, is fed not only by scientific curiosity, but by something emotional, an unfinished story calling us back. Pluto's moons, too, beckon with future promise. Charon, with its vast canyon systems and hints of ancient tectonics, remains largely unexplored. Kerberos and Styx, strange and tumbling, whisper of gravitational physics we barely understand. Nix and Hydra, bright with water ice, offer clues to the conditions of early collisions in the Kuiper Belt. A dedicated mission could reveal these worlds in exquisite detail, rewriting our understanding of binary systems and icy satellites. And yet, even as scientists imagine futures filled with spacecraft and measurements and data streaming across the void, there is another dimension to Pluto's forward story, one rooted in art, culture, and human imagination. Pluto continues to appear in films, in novels, in music, in poetry. Its heart-shaped basin adorns murals and posters. School children portray it with big, expressive eyes, offering sympathy for its demotion. And, what's remarkable is how this affection persists, even as scientific definitions shift. Pluto has become one of the few celestial bodies whose cultural presence rivals its scientific significance. In a way, Pluto stands alongside the Moon, Mars, and Saturn's rings in the collective imagination, not because of its size or brightness, but because of its story. A story of discovery, misunderstanding, redefinition, resilience. A story that mirrors the human experience. Artists often describe Pluto as a symbol of the outsider. Philosophers refer to it when discussing identity and validity, how something can retain worth even when a label is taken away. And teachers use Pluto to inspire curiosity, reminding students that science grows through challenge, not rigidity. But Pluto's future influence may extend even further. As humanity contemplates what it means to explore the solar system, not with probes alone, but with eventual human travelers, Pluto becomes a kind of gateway to the psychological frontier. It represents the idea of venturing so far from the sun that daylight fades into starlight. It symbolizes endurance, solitude, survival in extreme conditions. Writers sometimes describe Pluto as the threshold between the familiar solar system and the vast unknown beyond. And perhaps that metaphor is not merely poetic. Perhaps future missions, or even future star-bound technologies, will trace trajectories that begin at Pluto's orbit, using it as a stepping stone to darker and more remote realms. Well, there is another layer to this future as well, one more subtle but deeply compelling. Pluto's reclassification ignited global debates about scientific authority, public engagement, and the role of emotion in understanding the universe. Those discussions did not fade. They evolved into conversations about how science communicates with the public, how definitions are shaped collaboratively, and how curiosity can bridge the gap between experts and enthusiasts. Pluto, unintentionally, has become a case study in the philosophy of science. And, that influence may grow. Already, educational programs use the Pluto debate as a way to teach critical thinking. Students are invited to analyze definitions, examine evidence, and consider how categories are constructed. In a sense, Pluto is helping to cultivate the next generation of scientists, not by teaching them what to think, but how to think. But beyond science and culture lies something even more personal, more introspective. Pluto represents the part of ourselves that stands at the edge of the known, looking outward with both fear and longing. It embodies the tension between belonging and being different. And the way people fought for Pluto, defending it, mourning it, celebrating it, reveals that the universe is not merely observed, it is felt. We do not simply map the cosmos, we assign meaning to it, build relationships with it, let it shape our identity. In that sense, Pluto becomes a reminder that human beings are storytellers, even in the realm of astrophysics. We craft narratives around stars and planets because doing so helps us understand our place in the vast, cold expanse. Pluto's journey from planet to dwarf planet to cultural icon mirrors our own journey toward humility and curiosity. It teaches us to accept uncertainty, to embrace revision, to celebrate discovery even when it unsettles us. And yet, Pluto's forward path is still unfolding. Missions are proposed, definitions may change again, cultural fascination grows rather than fades, and as new telescopes peer deeper into the Kuiper Belt, discovering more worlds, some larger than Pluto, some stranger, some perhaps hiding secrets of their own, our understanding of Pluto will continue to evolve in response. This leads to another profound possibility, that Pluto's story may someday guide humanity not just outward, but inward. As we confront existential questions about life beyond Earth, about our responsibility to explore ethically, about the meaning of planetary identity, Pluto may serve as a touchstone, an example of how complexity, mystery, and humility coexist in the cosmos. And so, in this chapter, Pluto becomes the beginning of something rather than the end. It is the spark of future missions, the muse of artists and storytellers, the lesson of teachers, the symbol for those who feel small yet significant, the scientific puzzle that insists on being revisited, and perhaps most importantly, the reminder that the universe is not static or simple. It is fluid, dynamic, endlessly evolving, and our understanding must evolve with it. And as we follow this thread, this gentle forward pull in Pluto's narrative, we feel the story beginning to arc toward a final reflection. A question that has quietly lived at the heart of Pluto's tale from the very beginning. Not about labels or classifications or orbital mechanics, but about meaning. Because if Pluto can lose a title and become more beloved than ever, if it can shrink in official status but grow in emotional presence, If it can challenge scientific definitions while inspiring millions, then perhaps the true question is not what Pluto is, but what it teaches us. And that question, well, leads us toward the final thoughts waiting just ahead, where Pluto becomes not just a world in the darkness, but a guide in understanding how we navigate the universe and our place within it. Well, you see, as we come to the final winding stretch of this journey with Pluto, something gentle begins to settle over the story, like frost forming across a quiet window at dawn. Not an ending, exactly, but a soft slowing of breath, a chance to look back at all the terrain we've crossed and ask, with a kind of hushed curiosity, what it all means. And, perhaps that is the strange beauty of Pluto. The closer you think you've come to understanding it, the farther it seems to drift, inviting you onward with that faint glimmer of mystery it wears so naturally. And that is the thing. Pluto has never been just one story. It has been many stories layered together, scientific, emotional, philosophical, cultural. A story of discovery by a young astronomer scanning glass plates long after midnight. A story of a world so small and so far away that for decades it appeared as nothing more than a smudge of light. A story of triumph when it was named the 9th planet. A story of shock and heartbreak when that title was taken away. A story of redemption when New Horizons revealed a landscape so alive, so dynamic, so heartbreakingly beautiful that millions fell in love with Pluto all over again. And, a story that continues to evolve even now, reshaping the way we think about what a world can be. When you look back, you can almost trace the emotional arc of humanity through Pluto itself. At first, we projected hope, this tiny planet at the edge of everything, proof that the solar system still held secrets. Then we projected disappointment, feeling perhaps that the universe had betrayed some childhood promise, and later awe, pure, unfiltered awe, when the frozen heart of Pluto came into view, glowing softly across the void. It is rare for a celestial object to move us like that, to stir both scientific curiosity and human tenderness at once, but Pluto does. It always has. Well, and perhaps the most surprising truth is this: Pluto revealed more about us than we revealed about it. Every debate over its title became a debate about how we define meaning. Every argument about its place in the solar system became an argument about how we draw boundaries. Every emotional reaction to its demotion became a reflection of how deeply we long for belonging, even for worlds that do not know we exist. When New Horizons sailed past Pluto, completing a journey nearly a decade long, it felt as though humanity had reached out with a single fingertip and brushed the edge of a dream. For the first time, we saw the wrinkles and ridges of ice, the faint layers of blue haze, the vast basin shaped uncannily like a heart. We saw plains that move, mountains that rise, shadows that stretch across frosted deserts. We saw, in a sense, the soul of Pluto. The way its geology breathes and shifts, the way its atmosphere shimmers and collapses, the way time seems to move differently there. And, you might say that in that moment, something softened in the global conversation. The question of Pluto's status became smaller, almost irrelevant. What mattered was not the label, but the wonder, the closeness, the connection formed across billions of kilometers. People who had never cared about astronomy before found themselves gazing at Pluto's heart and feeling something stir, an ache, a tenderness, a strange sense of recognition. Because Pluto, in its quiet way, tells a human truth. You do not have to be large to be important. You do not have to dominate your orbit to matter. You do not have to meet someone else's criteria of perfection to be extraordinary. And perhaps that is why Pluto endures, not as a planet or a dwarf planet, but as a symbol of resilient significance. As we reflect on this long tale, it becomes clear that the universe is not interested in our categories. It does not arrange itself for our convenience. It simply is, vast, wild, beautiful, indifferent, generous, and our role, delicate and temporary, is to try to understand as much of it as we can, before our brief moment of consciousness flickers out. Pluto reminds us that understanding is always incomplete, and that is not something to mourn. It is something to celebrate, because the unknown is what keeps us moving, wondering, reaching. And when we consider this, the controversy over Pluto becomes something else entirely. Not a scientific dispute, not a cultural disagreement, but a reminder of how deeply we care about the cosmos. A reminder that even in an age of screens and noise and endless distraction, the human spirit still lifts its eyes to the night sky and whispers questions into the dark. What is out there? Who are we in the face of all this? What will we discover next? Pluto teaches us humility too. It shows us that we can be wrong, beautifully, wonderfully wrong, and that being wrong can open the way to truths far more magnificent than anything we imagined. If Pluto had remained a distant speck labeled planet, perhaps our curiosity would have dulled. Perhaps we would not have sent new horizons. Perhaps we would never have known the heart, the mountains, the flowing nitrogen, the hidden possibilities beneath the crust. Imagine that. Imagine never seeing the blue haze curling above Pluto's horizon. Imagine never learning that an icy world at the edge of everything could be alive. Imagine never feeling the jolt of awe when a world once dismissed revealed itself as a masterpiece of cosmic artistry. In that sense, Pluto's demotion was a blessing disguised as loss, a turning point that sparked deeper exploration, deeper reflection, deeper appreciation. And, that realization carries us into even deeper philosophical ground. Because Pluto's story teaches us that identity is not fixed. It evolves, just as our understanding evolves. Labels may change, but essence remains. Pluto did not shrink or fade or lose any part of itself when a vote was cast. It remained exactly what it always had been, a world of frozen storms and ancient ice, orbiting the sun with quiet persistence. The only thing that changed was our perception, and perception, as we know, is fragile. This brings us to the heart of the conclusion. Pluto shows us that the universe does not need our permission to be extraordinary. It simply is. And our task, humble, wondrous, impossible, is to keep noticing, to keep marveling, to keep searching for meaning in places where meaning is not guaranteed. As we stand here, at the edge of this final chapter, another truth becomes clear. Pluto is not the end of anything. It is a threshold. Beyond it lies the Kuiper Belt, full of worlds waiting to be explored. Beyond that lies the scattered disk, the Oort cloud, the dark frontier where comets sleep. Beyond all of that lies interstellar space, the vast cold ocean into which humanity may one day sail. Pluto is the gateway, a reminder that the solar system does not end where childhood diagrams told us it did. It stretches, expands, dissolves into mystery. And Pluto stands there like a lantern on the shore, marking the boundary between the known and the unknown. And so, as we close this chapter, we do not close the story. We breathe in slowly and look outward again. Because Pluto has taught us one final lesson, perhaps the most important one of all. Curiosity is infinite. And as long as we follow it, gently, courageously, with wonder as our compass, the universe will always reveal new stories. And that gentle truth guides us now into what comes next. Not an end, but a continuation. A wider exploration. A new horizon beyond the horizon we thought we knew. Where Pluto's story becomes the beginning of something far larger. And so we turn the page, softly, letting the cosmos whisper its next question into our waiting hands.